My name is Glenn Hunter. I'm with Hydrologic Process Equipment. We represent Bay Products in this area, among other companies, including Prominent, which is your chlorine monitoring equipment. Bay Products is a manufacturer of odor control equipment. They do carbon, they do biofilters, and bioscrubbers, as well as wet chemical scrubbers. Carbon is the system that you have at your sludge receiving facilities. It's 2 deep bed, 6-foot diameter, activated carbon filters. They're designed, and carbon is designed to remove reduced sulfur compounds from wastewater. Now, reduced sulfur compounds, everybody's familiar with hydrogen sulfide. There's a little thing in the back of your guide which puts words to what you're smelling. I don't know who came up with it, but it's kind of, and it's relatively well published. In fact, Bay Products got it looks like out of this MOP 25, which is all odor control. It's gotten to be a real science these days. Odor control is not just a nuisance anymore, it's serious business. Because what's happening is people are building houses right next to treatment plants and pumping stations, and they're not putting up with it as far as the smell goes. It used to be just, well, you know, you built next to it, you should know better, and that's the way it's gonna be. Not anymore. Now you guys, are charged with doing something about it. And fence line, if it stinks outside the fence line of your pump station or treatment plant, you need to do it. You need to take action when somebody calls and complains, whether it's a resident or a customer or whatever. You need to go out there, get their names, find the wind direction, smell along with them. As discussed just previously, activated carbon is designed to treat reduced sulfur compounds. There's a number of odors here that are not reduced sulfur compounds. The fishy, or I don't know what cream corn smells like, but I'm sure it's kind of unpleasant or putrid. Reduced sulfur compounds are dimethyl sulfide and hydrogen sulfide primarily. The fishy aromas are related to amines, which are a different compound. It's from a different breakdown other than a sulfur breakdown. What we talked about is you're getting sludge from who knows where. When an engineer designs a system, what they do is they take field measurements of what is currently going on there as far as what odors, what's off-gassing at the time, and what they can treat. And what they do is they design a system based on what's out there. If that changes, then you got to look at another method or another approach. Yeah, it makes it a moving target. But I haven't spoken with Mark Gould. I'm not sure what his conclusions were, but I mean, you're lucky to have CDM as your engineers. These guys are, I would say, the top odor control group in the country. They'll get to the bottom of it. We just supply what they ask us to. They do the design. We just say, here it is. We just build it. There's a whole litany of different odors that you can look at. Some are effective with carbon. Some are effective with a biological type of a treatment. Some are effective with a bioscrubber type of a treatment, and some are effective with a wet scrubber type of treatment. Carbon by far is the simplest to operate. It's either there or it's not. It's designed, as I say, for reduced sulfur compounds. When it breaks through, when sulfur breaks through, when hydrogen sulfide breaks through, because we did extensive measurements on that, and we are getting removals of hydrogen sulfide. On one vessel, it was 99.99%, and the other vessel was like 99.98%, which is a little better than ivory soap. Ivory soap's 99.6. So it's doing what it's doing what we asked it to do.
He had talked about getting more extensive tests, and he said maybe we may
Yeah.
put a stack on top.
That would probably be the best, most immediate approach. Sure. Because as you look at it now, there is no stack on the discharge.
Yeah,
It's just a blind flange coming up.
Flapper on the side, it's wide open.
Mm-hmm.
I guess as far as I heard the basic plans were, that was only supposed to be like a chicken wire open anyway.
Just a bird screen, right? Just to keep the sparrows out. But anyway, what you have is a deep bed system. You have fans coming in, taking untreated air through a fan to the bottom of the system, and it blows up through a bed of carbon. And the sides of the vessel in the carbon, there's 3 ports. And those are sample ports. You can either use a device or use your nose to tell and see if you can detect hydrogen sulfide or sulfides at each of those layers. You will be able to tell at the 3 ports and be able to determine when the carbon is being spent. Carbon works on the principle of adsorption. What it does is it has surface pores in it. It has huge surface area for what it is. And sulfur and reduced sulfur compounds just stick to the outside. There's no real chemical reaction. It just has surface area on the carbon, and it just sticks to it. When all the sites have a little carbon molecule or a little sulfur molecule on it, it's used up. Throw it away, get some new stuff. There's a damper on the device, and we'll go out there in a little while. There's a damper on the device which restricts the flow to 1,000 CFM per unit. That's marked and pinned down, so that shouldn't move at all. Should leave that exactly where it is. Then there's the equipment, which is the duct material, which is fiberglass. There's a grease mist eliminator, which is just like a pad. They put them on kitchen range covers. It's just a stainless steel pad which slows down the flow of moisture and grease and collects it there. Occasionally that will have to be taken out and steamed or pressure washed. When you determine that the pressure drop based on the pressure meters has reached a certain point, and what we'll do is we'll go out and check them now, and then we just keep and monitor them, what the pressure readings are. There's a fan, motor, belts. You guys are as familiar with that as anything else. I mean, it's the carbon sits on a fiberglass grate, like a walkway, with a fine polypropylene mesh on top of that. There's sample valves that we discussed. There's an overflow drain. It's actually for a water regenerable carbon, which you don't have, but you have the option of using it. Water regenerable carbon can be washed. It has to be thoroughly washed. The whole vessel's filled with water. It's drained. You get a real low pH effluent from that. Wash it again and again and again, and it can be reused. Unfortunately, what happens is some of the stuff doesn't wash off. So every time you use it, you have a little bit less time for it to be used. So the new catalytic carbons they have now are lasting longer than the water regenerable carbons even after a number of washings.
What's the usual life expectancy?
This particular, well, that's a good question. This particular vessel was designed around a specific hydrogen sulfide concentration. Now, depending on how strong it is, will determine the life of the carbon. At 20 parts per million, I believe it was to last for 185 days. At 10 parts per million, it's expected to last for 225. When we were out there and did sampling, we measured between 10 and 7. So you're looking at 8 months to a year.
Glenn, can I ask a question? Is that at 1,000 CFM per unit, or is that the maximum level of the design for the unit, 2,000 CFM?
1,000 CFM per unit, and concentration of the hydrogen sulfide at 20 and dimethyl sulfide at 10. So it's an incremental drop depending on what your concentrations are.
So
But it's designed for 1,000. Each vessel's designed for 1,000 CFM.
That's it.
In the O&M manual, there's a table on the expected life and the criteria that went into that. The other than just using your nose, you can also sample the carbon, and it can be tested for to see if it has any capacity left for adsorbing odors. We're not going to talk about regeneration. We actually already did briefly. Do we have approved O&Ms?
Approved training?
Approved training, but we don't have an approved O&M manual?
I don't believe so, no.
Okay. The grease in the motors and the pillow block bearings were greased at the factory, and they would be probably due for greasing from a year from shipment. I'm not sure exactly when that was. I think it was last winter sometime. So you're looking at a couple more months, and we will. At which time you'll have to grease flush out the motor bearings and grease the pillow block bearings on the shaft of that. But that's really all the greasing that needs to be done. It's a pretty simple system. And then we talked about the different types of odors. You know, some of them are stronger than others. Some of them are harder to capture than others. But as far as sulfides goes, that's the preferred way to do it, just because of simplicity. Can we go out to the tanks and see what we can come up with? Okay, what these are just fiberglass vessels. You've got from here down is just empty space where the air travels through from the fan. There's a fiberglass grating like you would have in the floor with a fine polypropylene mesh and granular carbon. You probably see it. There's some on the ground over here. It kind of looks like rabbit food. And that's just sitting in there. You're pushing air across that bed. And it vents out here. These are the sample ports of which you should use a meter to monitor and tell if it is breaking through. You can determine the life based on the measurement of hydrogen sulfide, the lowest, which it hits first, here and here, and try to determine exactly when your carbon is going to break through for the hydrogen sulfide. I'm sure you guys have handheld hydrogen sulfide monitors all over the place. From there, it goes out and discharges, and I guess they're talking about putting a vent stack up to the roof. This here is I guess it's just a temporary ground. And what this is a ground that's going up through the carbon, because when you're passing air through it, you're creating friction, static electricity. Carbon will go if there's enough spark to it and heat. So it's got to be grounded. You have a flow monitor here, flow and pressure monitor here, fan, flow pressure monitor here as well. On the grease mist eliminator, when you see a pressure drop, and I believe it is, I gotta check the manual. And unfortunately, that's one of the things that was left out of this this draft copy. You're also going to see, as it goes through the fan, bottom of the vessel, you have a pressure there, which is monitoring pressure on the inlet, which is the high pressure side on the bottom, and the discharge, the low pressure side on the top. And if it were connected, it would work. The design of this with the automatic dampers, I'll get another one, and we'll come back and replace it. The design on the automatic dampers on top of the sludge